Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Right, let's have a look at these ones. So find the value of x in each of these equations, and you can see you have indices again. So the first thing I would do in practice is open up my log tables. Okay, so I'm just going to copy them over here so we have a copy and we're not flicking over and back. Okay, so there's my rules of logs or rules of indices. So find the value of x. Okay, so 2 to the power of x is equal to root 2 over 2. Okay, so let's try that first one. 2 to the power of x is equal to root 2 over 2. Now what I want to have is 2 to the power of something equals 2 to the power of something. Okay, why do I want that? Well, when I get to that stage, I can drop the base numbers because they're the same, and I can equate the powers. Okay, why can I do that? It's because of this equals to sign in the middle. So the only way the left-hand side can equal the right when the base numbers are the same is if the powers also are equal. Okay, so in other words, I could have an x plus 1 there and I could have a 7 there. Okay, so I would end up then just dropping the base numbers and letting the powers equal each other and solving it. Okay, and now you can see I have 2 to the power of 6 plus 1 on that side when equal to 2 to the power of 7, and you can see how they're equal. So that's where I'm going. And I just need to do a few rules of indices first. Okay, so I need to resolve 2 to the power of x is fine on the left. I need to sort this side out. So let's have a look at him. So 2 to the power of x is equal to, okay, so the half or the root 2 is always to the power of a half. And that's one you will end up learning off by heart. You won't even think about it when you see root 2. You'll immediately put down 2 to the power of a half. But where does it come from? Okay, so a square root sign has a 2 there. If there's no number written there, it has a 2. It's just so commonly used, the square root sign, that 2 tends to be not written in. And that's why square and square root are the opposite of each other. Okay, so there is a 2 there. Okay, so therefore if I apply this rule, which is telling me how to write it as an indices, it's saying take the base number. So can you see the base number is a, so take the base number and it's to the power of 1 over 2. So my base number is 2, it's what's under the square root sign, and it's to the power of a half, 1 over 2. And then underneath the line, 2 written on its own like that is 2 to the power of 1. Okay, then I use this rule here, which is when you're dividing powers, and as long as the base number is the same, which it is in this case, that's why that letter is the same. Okay, if there were different base numbers, this would be an A and this would be a B, but they are the same letter, which implies that the base number has to be the same. And therefore it's then telling me, if you can see that, to subtract the powers. Okay, so 2 to the power of x on the left, not much I can do with that. So just top minus the bottom. So then 2x is equal to a half minus 1 is minus a half. Okay, and that's us done. So you can see the base numbers are the same now, and now I equate the powers. So x is equal to minus a half is your answer. Okay, now to convince yourself that's right, put into the calculator 2 to the power of a half, that's the left hand side, and then put into the calculator root 2 over 2. Okay, so separately do that. Okay, 2 to the power of a half is 1.4142, blah, blah, blah. Root 2 then over 2. Oh, I put in the calculator wrong. Root 2 over 2. S to DM. Oh, minus a half would have been handy. 0.707. My apologies. It's minus a half here, not a half. So 2 to the power of minus a half is 0.707. Okay, so that's all you're doing. You're solving that power using the rules of indices. Okay, and you can always check your answer just like we've done here. You don't have to write it down if you don't want to, but you can check it on your calculator. Okay, let's try part 2 then. 25 to the power of x is equal to 125 over root 5. Okay, so a trick of the trade, you bring it down to the lowest common multiple, I suppose. So 5 divides into all of them, so you'd bring them all down to the power of 5, because remember you need the base numbers to be the same in order to let the powers equal each other. Okay, so how do I do that? Well, how do I rewrite 25 with the base number of 5? So it would be 5 squared. Okay, put that into a bracket and put the x outside it. Okay, so that it is literally just this 25 up here that got rewritten as 5 to the power, or 5 squared. Okay, 125 then, and you're on your calculator and you're just doing 5 by 5 equals by 5 equals, and you're keeping a count of how many 5s you have. Okay, so 5 to the power of 3 is 125, and then root 5. So this is why I'm saying you'll get so used to root 5. It's got the little 2 there. That's going to be 5 to the power of a half. Okay, and when you come on to the calculus chapter, whether that be in 5th year or 6th year, you'll again use that power of a half over and over again. Okay, so I need to resolve the left-hand side now. I have a power to a power. Okay, so it's rule 3. Okay, don't confuse rule 1 with rule 3. The difference between them, if this was rule 1, for example, it'd be 5 squared 5 to the power of a half, or 5 squared 5 to the power of x, and in that case I would add the powers. Okay, it would become 5 to the power of 2 plus x. But this is 5 squared, so it's power to a power, so it's rule 3, and it's telling me then to multiply the powers. So that's the difference between those two rules. The base number only appears once when you need to multiply them. Okay, so we're going to get 5 to the power of 2x there on the left, and then on the right it'll be top minus the bottom. So 5 to the power of 2x then is 5 to the power of 3 minus a half. It's 2.5, which is what? 5 over 2. Okay, and now look what we have. We have a base number to a power in its simplest form, base number to a power in its simplest form. Now we drop the base numbers. So we have 2x then being equal to 5 over 2. Divide both sides by 2 like you normally would. And x is equal to 5 over 4. Okay, let's try the third one. I'm just going to add on a new page so we're not squishing anything. Let me go back from my rules. Okay, let's try the third one. We have 1 over 8 to the power of x equal to root 2. Okay, so again here, if you look at the two numbers, then 2 is the obvious base number, okay, because 2 by 2 is 4, 4 by 2 is 8. Okay, so I could write 1 over 8 to the power of x as 1 over 2 to the power of 3 all to the power of x. Okay, is equal to 2 to the root 2 will be 2 to the power of a half. Let's resolve the bottom here. I have multiply the powers. No, sorry, wrong one. This one here, multiply the powers. So I have 3x, and this one I just have 2 to the power of a half. Okay, this one's on the bottom. Can you see that? It's 1 over 2 to the 3x. So not quite at the situation where I can drop the base numbers. I need to use this rule here, the reciprocal rule, where I can literally move things above and below the line. And in this rule, when you move something above or below the line, the power changes sign. Okay, so how would this one work? Well, to bring that above the line, it would be 2 to the power of minus 3x. And that's equal to 2 to the power of a half. Okay, so that rule here. And now I can drop the bottom, the base number, and I can let the powers equal each other. 3x is equal to minus a half, and divide across by 3. And you get minus 6. Okay, so again, same theory, just let the base numbers equal each other and then equate the powers. Okay, so the last one then, 1 over 3 root 7. Okay, so the base numbers are the same in this one, so we don't have to change anything. So that left-hand side is fine. Now 3 root 7 will be this one, where my q is 3. So it's 7 to the power of a third. Okay, need to bring it above the line. So it's going to be this one. So it's 7 to the power of minus a third. Drop the base numbers, equate the powers. Okay, so once you get in on these, they're not too bad. Just the rules of indices, and try and think where you're getting to. Have the base number the same, equate the powers. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.